Good morning, students. I'm Abhijit, and as you know, we have discussed about the principle of moment. According to principle of moment, we know that the algebraic sum of moments of all forces acting on a body about the axis of rotation, then the body is said to be in a state of equilibrium. That is, sum of all anticlockwise moments is added to the sum of all clockwise moment is equal to 0. If we take the anticlockwise moment, the sum of anticlockwise moment as x, then the sum of clockwise moment should be taken as minus x. This is the only condition to get 0 as the sum. So that means this x is equal to this x. That is, the anticlockwise sum of anticlockwise moment is equal to sum of clockwise moment. So simply we can say that in other statement that according to principle of moment, the sum of clockwise moment, the sum of anticlockwise moments is equal to the sum of clockwise moment when a force applied on a body about its axis of rotation and the body is at rest. That means it is in the state of equilibrium. These are the conditions that the body will satisfy if it is in the state of equilibrium. Let's see, this is one of the example. Suppose this one is a system where this one is a dumbbell shape, this one is a body in the shape dumbbell. Here it is at rest on the ninth edge at the point M, and this point M on the left side of point M, L1 is the length, and this is suppose the weight. Actually, if F1 is any external force, in the absence of any external force, the weight actually considered as the force. So this weight is actually the acting force on this length. Now this one be taken as W2. So on the right side of L point, L2 is the total length and W2 is the effective force here. Now we will calculate what is the moment of force due to the weight W1 and W2. So simply we can write that this W1 is the applied force and into this L1 is the perpendicular distance from the pivot. Here M is the pivoted point. L1 is the perpendicular distance from the point M to the axle, line of axle. Here W1 is the force. So similarly, if the body is in the state of equilibrium, then simply we have to write that this moment on the right side, this is actually the anti-clockwise moment, is equal to the clockwise moment, that is W2 into N2. So this condition will arise if the body is in the state of equilibrium. Now there are three different conditions. One, suppose that we consider the length L1. This is the length L1. This is greater than the length L2. This length is greater than length L2. Then this equation will satisfy only if this, see, our condition is if this L1 is greater than L2, then this equation, this relationship will satisfy only when this W1 is lesser than W2. Okay, if L1 reduces, W1 should be greater, and if L1 is increases, suppose L1 we take greater than L2, then W1 should be smaller than W2. This is the condition. The second condition again, if L1 is smaller than L2, then this W1 should be greater than W2. There is one more condition that you can guess easily by rote. That is, if L1 is equal to L2. Okay, that means M is the midpoint. Here M is midpoint. Okay, so then W1 should be equal to W2. That means load on both the sides will be equal in such a case if M is the midpoint. Okay, so these are the three conditions will arrive. Now just think that if we shift the point M, if we shift the point M toward the left, then what happens? Then L2 is reduced. If we shift point M toward right, then L1 is reduced and the weight is same as it is. So L1 into W1 is decreased. If we shift L1 to the left, then first L1 decreases, and due to the decrease of L1, what happened? The moment due to weight W1 is also decreases. So what happened? The anti-clockwise moment will be smaller as compared to the clockwise moment, and the body is not now in the state of equilibrium. Now one more condition if we consider, if we shift the point M toward right, then what happens? Then L2 decreases, and due to the decrease in L2, what happens? W2 into L2 also decrease, and then what happens? The moment, the clockwise moment is decreases. So if the clockwise moment is lesser than the anti-clockwise moment, then simply the body is not in a state of equilibrium. So my point is that in this particular system there is one unique point. There is one unique position where the body is in the state of equilibrium. Here in this particular case, M is the unique position, M is the unique point of the body, and when forces are applied on the body about the axis through M, then the body comes in the state of equilibrium. So what is the importance of M here? This point M has some importance. Then what is the importance of M here? Let me tell you about this. Now we consider a different type of body. To know about this body, to know about the internal concept of the body, we consider that the body is made up of a large number of tiny particles. All the particles are projected here as A, B, C, D. Suppose this A is a particle, is a point particle here inside the body. P, Q, R, S are also the point particle here inside the body, and all the individual particles of the body has their own weight. So let us consider that this P has the weight WP. This P represents a particle. This D has the weight WD. In this way, this R has the weight WR. This Q has the weight WQ. This M has its own weight WM. So in this way, all the particles have their own weight. Okay. So now we suppose that the body is pivoted at this point M. The body is actually pivoted at this point M. Now there are several forces in the form of weight of different particles acting on the body. Now see, suppose this is, again we consider the same body here in the different form. Here the particle A is, see this one is a particle. This particle A apply a force due to its own weight, that is WA, downward in this direction. Okay, so this is the line of action of force, clear? And M is the pivoted point. So the distance from M to line of action of force is equal to A dash M. So here we can calculate the moment of force. The moment of force at the point A is equal to WA, which is actually what? The weight, the force, the applied force, this is the weight, and it is into A dash M. A dash M is the perpendicular distance, you can see. Okay, simply here the point P is considered here. This is the point P. So the point P has its weight WP, and the line of action is like that. This gives the line of action of this way. Now the perpendicular distance is M P dash. So the moment of force at the point P should be equal to the weight of P into the perpendicular distance. Here it is P dash M, see P dash M. So in this way, here the point D is there. Na? So the distance from the line of action of the particle D is actually 0. See, this is the line of action. This line is exactly near the pivoted point. So the distance is 0. So the moment of force at the point D is equal to WD into 0, which is equal to 0. So in this way, we can calculate the moment due to different weights. Okay. Now see, we represent X as the moment of force here. Now this body is pivoted at the point M, and due to the weight of the particle A, the moment will produce that causes the anti-clockwise rotation of the body. That means XA, which is actually the moment at the point A. The moment of force at the point A is actually the anti-clockwise moment. Now again, see, on the left side of M, whatever the point, the point B, so that means XB also the anti-clockwise moment. C is also on the left side, so XC also the anti-clockwise moment. These are the anti-clockwise moment are added about the axis through the point M. Now the clockwise moment are, see, Q is on the right side, so P, actually it is XP, the moment of force at the point P plus moment of force at the point Q plus the moment of force at the point R. Because moment of force at the point S is 0, it is near the rotational axis. So the distance is 0, so the moment of force at the point S is 0. So these are the anti-clockwise moments, and these are the clockwise moments. So if the body is in a state of equilibrium, that means it is at rest. So if it is pivoted at the point M, then the anti-clockwise moment should be equal to the clockwise moment. This is the principle of moments. Now, as we have a question, that is, what is the importance of the point M? So here M has the point M is actually called the center of gravity of the body. When the body is about to rotate through an axis which passes through the point M, at that condition the body will comes to the state of equilibrium, and at certain condition these conditions is satisfied. That is the sum of anti-clockwise moment, so the axis to M, and the sum of clockwise moment again so the same axis is equal. Then it is equilibrium, and this is only possible when the axis is the rotational axis is actually passes through the important point M, and this point M is called the center of gravity. This M is represented as G. This point M is represented as G. G means center of gravity. Now think a condition, if I change the shape of this body, then the position of point M must be changed. That means the position of center of gravity G, that is here we have considered as M, is completely dependent on the shape of the body. If the shape of the body changes, then the position of center of gravity will also change. So for this, consider that if this one is considered as a body, it has center of gravity at at its center. Okay, so here the point M exists here at the center. Now suppose I just want the paper like this, then its center of gravity changes and it is somewhere else now. So if we change the shape of the body, then it changes the position of center of gravity. Now the second point about the center of gravity is that the center of gravity may or may not be inside the body. It means that the center, the point which represents the center of gravity, it may be inside the material of the body or may be outside of the material of the body. Like if you consider a wire, then wire is in the shape of cylinder. Then wire has its own center of gravity. But if we suppose this one is the wire, this is the center of gravity. Now if we make a coil by this wire, then the center of gravity of this body, which is reshaped, is now not inside the material, it is here at the center of the coil. So the center of gravity does not depend on the, is completely depend on the shape of the body. Okay, it may be or may not be inside the material. Now think that the point M has its own weight Wm. It is the weight of the particle which is at the point M. If we consider the particle at the point M, here M represents a particle only. So alone M, if M exists alone, then it has the mass Wm. But if in this particular shape of, if M exists in this particular shape of the body inside the material or somewhere else in the body, then this M, which is actually the center of gravity, gives or proposes all the weight of the body. That means this is the shape of the body and here is the point M. So this W, that means this W is actually the weight of the sum of weights of all the objects. So this point M propose or apply the weight vertically downward, and this only this particle will apply. So simply, if we take any body, its weight, the force that the body apply downward, vertically downward, and this force is through the center of gravity of the body. Here are some of the shapes, like this one is a cylindrical shaped body. Its center of gravity exists here on the axis, on the middle of the central axis. This is the sphere. Its center of gravity is at the center. This is a cuboid shape. Its center of gravity is the point where the diagonals intersect. And this one is represent a coil shaped body. When it is horizontal, it is on the horizontal plane, then its center of gravity is at the center. See, center of the center. Now this one is like a meter scale, 1 centimeter to 100 centimeter. So this one length by 1 meter. So its center of gravity is exactly on the reading 50 centimeter. Okay, here its center of gravity. So see, the weight of each of the body is along the center of gravity, the point where the center of gravity exists in the body. Now if we have any irregular shaped body like this one, then how we can find out the center of gravity for this? Let me show you. See, this is the activity that you can do in your home. We have a flat rectangular object and we have tied this one here and just draw a line, and in this way this body is tied by different positions. Here, see, this one is the position B, this one is the position A. So here, by drawing the line, there is a specific point where all the lines are intersect, and this point gives the center of gravity. So students, this is about center of gravity. The center of gravity is the point which propels the entire weight of a body. Its position is unique. Why it is unique? Because the algebraic sum of moments of all weight above this point is equal to 0. That means all the moment about the center of gravity is equal to 0. So thank you class. Do the numericals and revise it. Thank you.